In this unit, we're going to talk all about files and folders. In short, files are the basic unit of information that you as the user deal with, and you organize these files into what are called folders. At the start, however, we need to back up and first talk about how any information at all is stored electronically. In all likelihood, you've encountered the term bit. Bit is short for binary digit, and it's the smallest possible piece of information. A bit is simply anything which has one of two states, and normally we symbolize these two states as 0 and 1. What the two states mean, what they represent, is up for grabs. It could mean that something is either on or off, it could mean either yes or no, or true or false, etc. Now, the actual physical mechanism, which is in one of these two states, differs from one technology to the next. The simplest example of a technology that represents a bit would be like the flag on a mailbox, because that flag is either up or down, and it's used to represent these two states. Either there's mail to be had, or there's no mail. Obviously, in computers, the physical mechanism is electronic in nature, but the end goal is really just the same. Some kind of mechanism which can switch between these two states. In a computer, that might be some piece of circuitry, or it might, say, be some electrical charge on a magnetic surface. It varies from one technology to the next. In any case, an individual bit by itself is not terribly interesting, but if you use multiple bits together, we can represent more interesting kinds of information, like, say, numbers. Now, how exactly this is done is a bit beyond the scope of our discussion here, but in brief, the idea is we need to convert from the counting system you're familiar with called decimal, you need to convert it into the alternative counting system called binary. Because in the binary system, you only use two symbols, 1 and 0. And so a number in binary form can naturally be represented using a series of bits. So, for example, if you wish to represent the value in decimal we call 22, written 22, that same quantity in binary, for reasons I won't get into, is written 10110. And so we can represent the quantity 22 using 5 bits. So that, in brief, is how we represent numbers, but what about more interesting kinds of information like, say, text? Well, it turns out that we can represent text using numbers, and as we just explained, numbers can be represented using bits. The way we can represent text as numbers is to simply assign to each character a unique number. So, for example, imagine I wish to represent this text here, A space banana. Now, in this text, there are 8 characters in total, but only 5 of these are unique, because uppercase A is repeated 3 times, and uppercase N is repeated twice. Also note that an uppercase A is a distinct character from a lowercase a, and actually the space itself is a kind of character. So for each of the unique characters here, lowercase a, space, capital B, capital A, capital N, I need to arbitrarily assign to each of these a unique number. And so, supposing I assign to lowercase a the number 97, to space the number 32, to capital B the number 66, to capital A the number 65, and then to capital N the number 78, this is how I would represent this text in numbers. I would represent it as 97, 32, 66, 65, 78, 65, 78, 65. Now, of course, when I record that data, that series of numbers, the important thing is that I, or whoever is reading that data back, needs to use the same mapping of characters to numbers. There's nothing inherent in the number 66 itself that indicates that it represents uppercase B. That was just an arbitrary decision I made. So whoever is writing this data needs to effectively agree with whoever is going to be reading this data about which characters map to which numbers. And because it would be a huge headache if every program and every computer in the world used its own mapping of characters to numbers, instead, most programs use standard mappings called character sets. Most programs in the world today use a character set called Unicode, and so text data written by most programs should be readable by most other programs. So, that's the basic idea of how text is represented as bits. But what about an image? Well, if you zoom in on a digital image, you'll find that the image is actually made up of these discrete points in a grid, and each one of those points is set to just a single color. Usually these points are represented as little squares, as they are here, and they are called pixels, which is a combination of the words picture elements. Each pixel is an element of the image. So now, if an image is made up of these pixels, to represent an image we need to represent the individual pixels. and to represent an individual pixel, we need to represent a color. And so how do we represent colors? Well, it turns out we can use the same trick we used with text characters. We just need to map each unique color to a unique number. Once we've done that, we can represent each row of pixels as a series of numbers. And so because a whole image can be represented as a series of rows of pixels, we can represent the whole image as a series of numbers. Be clear here that, like with text, the decision of what number corresponds to what color is really totally arbitrary. The important thing is that in the end, when the data is sent from the computer to your monitor, your display device, the important thing is that your monitor is hardwired to display the right colors given the right numbers. So once we can represent images, it's then fairly obvious how to represent a moving image. A moving image, like a video, is simply a series of still images displayed one after the other. How to represent audio is less obvious, but again the general idea is to reduce it to a series of numbers. When audio is recorded by a microphone, it is translated into an analog electrical signal. This analog signal can be represented as a wave, and so to translate it into a series of numbers, what we do is we take a sample point at regular intervals along the wave, and we record the height of the wave at each of those points. Thus, an analog signal can at least be approximated as a series of numbers. The more samples of the wave you record per second, the more accurate a representation of the wave you get. To get CD quality sound, you need to record at about 40,000 samples per second. Now, to convert an analog signal into these digital samples, you need a special chip called an analog to digital converter, and to go the other way, to convert from digital samples into an analog signal, you need a chip called a digital to analog converter. So you'll find such chips in any digital device that's capable of recording or playing back sound. We have a number of important terms to describe multiples of bits. First off, a byte is 8 bits. We also have these prefixes, kilo to mean 1,000, mega to mean 1,000,000, giga to mean 1,000,000,000, and tera to mean trillion. So if I say kilobyte, I mean 1,000 bytes. If I say gigabyte, I mean 1,000,000,000 bytes. And you have to be careful not to confuse bits with bytes. If you say megabit, that means 1,000,000 bits, but if you say megabyte, that means 1,000,000 bytes. So a megabyte is actually 8 times the number of bits as a megabit. You have to be especially careful about this distinction between bits and bytes with abbreviations. In the abbreviation KB, it doesn't matter whether or not the K is uppercase or lowercase, but if the B is lowercase, that's supposed to mean kilobits, and if it's uppercase, it's supposed to mean kilobytes. In most contexts, people talk in terms of bytes rather than bits, so they will talk in terms of, say, a gigabyte rather than a gigabit. However, terms of bits are generally favored when talking about data transfer speeds. So, for example, the internet connection I get from my cable company is advertised as 10 megabits per second. I wish it were 10 megabytes because then it would be 8 times as fast. But sadly, it's just 10 megabits. When talking about data storage, however, the convention is to talk in terms of bytes. And most storage devices these days have a total capacity of some number of gigabytes. There are many different types of storage devices, but here are pictures of the 3 most commonly used today. On the left is a picture of a hard drive. A hard drive is about the size of a large paperback book or maybe a deck of cards, and it's usually placed on the inside of your computer. Hard drives are generally your highest capacity storage option. Today, here in 2010, you can buy a hard drive for about $100 that has about a terabyte, which is 1,000 gigabytes, which is probably more storage than you'll ever need. In the top right corner here is a picture of what's sometimes called a flash drive or a thumb drive. These things are very small, about the size of a stick of gum or smaller, and this one here can store 16 gigabytes. And these things are handy because it's a decent amount of storage you can carry around with you, like say put it on your keychain. In the bottom right here is a DVD drive, and these drives can read the DVDs that you rent from the video store, and also they can read DVDs with any kind of data stored on them. It doesn't necessarily have to be video. A single DVD can store a little under 5 gigabytes. The problem with DVDs, though, is you can't write to them in the same way that you can write data to a hard drive or to a flash drive. Most DVDs are actually created in a mass printing process in a factory, and the data on these discs can't be erased or changed. However, you can buy blank DVDs which you can actually write to. The problem still, though, is that writing to these DVDs is really very slow and cumbersome, and most blank DVDs can only be written to once. Once you've written something on the disk, it can't be erased. So if you have some data which you want to archive, putting it on a DVD might be an okay solution, but it's generally not the sort of medium you write to on a casual basis. Especially in the case where you have some data that changes frequently, you're going to want to store that on a hard drive or a flash drive, not a DVD. Now, in a typical computer system, you have at least one hard drive and one DVD drive, but you might have some number of additional hard drives, maybe some additional DVD drives, and then also some number of flash drives plugged in. And so in Windows, we need some way to distinguish between these drives, and what Windows does is it assigns each drive its own letter. And when written, these drive letters are usually followed by a colon. So, for example, on a system, I might have a C drive, a D drive, an E drive, an F drive, and so forth. Now, when we store data on a drive, we do so in units called files. Files come in all sizes, from a handful of bytes all the way up to some number of gigabytes. Each file has a name, and to keep things more organized, files are divided into directories, which are also called folders. Like files, directories themselves have names, and a directory is simply a list of the names of files and other directories contained within it. So because directories can contain other directories, what you get in effect on a drive is a hierarchy of directories. At the top of this hierarchy, you always have a special directory which doesn't have a name, but which is called the root directory. Effectively, all of the files and directories on a drive are contained within this root directory. So for example, imagine I have a storage drive which Windows has assigned the letter C. Here we have a diagram of its directory structure. At the top of the hierarchy is the root directory, and inside that directory are two other directories, one called Music, the other called Pictures. And then inside the Music directory itself are two other directories, one called Beatles - Sgt. Pepper's Lonely Hearts Club Band, and the other called Talking Heads - Stop Making Sense. If we list the contents of a directory, we should see the directories contained directly within it, and also any files in that directory. So in this example, when we look at the root directory itself, you will see inside it are two directories, one named Music, the other named Pictures, and it happens to have also a file called businessreceipts.xlsx. For another example, if we look inside the directory called Beatles - Sgt. Pepper's Lonely Hearts Club Band, then we see these 13 files, each one of which is an audio file. It's a track from the album. To uniquely identify any directory or file on your system, you can write what's called a file path. A file path includes, in order, the drive letter, and then all of the directories in which the thing is contained, and then the thing itself, the directory or the file. And these components of the file path are all separated by a backslash. So, for example, the file path to the directory Beatles - Sgt. Pepper's Lonely Hearts Club Band is written as C:/music/Beatles - Sgt. Pepper's Lonely Hearts Club Band. And because this is a path to a directory, we end with another backslash. The path to a file within that directory is written the same, but with the name of the file at the end, and notice it doesn't end in a backslash because this is a file, not a directory. When it comes to these file paths, Windows is actually not all that picky. First off, you don't necessarily have to use backslashes. Windows is perfectly happy if you use forward slashes instead. Also, for a path to a directory, the convention is that it should end in a slash to designate that this is a directory and not a file, but it's actually okay if you omit the slash. Also, when you name your files and directories, Windows keeps track of which letter cases you use, say whether you use an uppercase W or a lowercase w, but then when you write a path, Windows doesn't care if you use uppercase or lowercase. So here the path C:/Windows with an uppercase O, W, and S at the end is actually the same path as the ones above it. Because of this laxness in paths about letter case, you can't in a directory have two things with the same name except for different letter case. As far as Windows is concerned, they actually have the same name. When it comes to assigning drive letters, for historical reasons on most systems, you'll find that the main hard drive is assigned the letter C, and then the DVD drive is assigned the letter D, and any drives in addition to those are assigned the remaining letters, starting from E. For historical reasons, the letters A and B usually go unused. When you name a file in Windows, by convention the file's name should end in what's called a file extension. A file extension is a dot followed by some number of characters, usually just 3. And the idea of the file extension is that it denotes the type of the file. So, for example, some common extensions include .doc, which is the extension used by Microsoft Word documents, .xcl, which is used by Microsoft Excel spreadsheets, .jpeg, which is a kind of image format, PDF, which is another kind of document read by this program called Adobe Acrobat, MP3 is a popular audio format, AVI is another common video format, .html is the format for web pages, and .exe is short for executable. It's an executable program. It's a piece of code that can actually run. These are just a sample of the most common extensions. You'll commonly encounter a couple dozen more. The Windows operating system itself has a bunch of files, and these are placed in some standard directories. Assuming Windows has been installed on your main hard drive, and your main hard drive has been assigned the drive letter C, then you should find the Windows directory itself at c:/Windows. This is the directory which contains almost all of the files used by Windows itself. As a user, you generally really don't have any need to go into this directory. None of the files in there really concern you. You should also have on your system a directory called Program Files. By convention, this is the directory where any files for any other programs installed in your system should be placed. Also on the same drive where Windows is installed, you should have a directory called Users. For every user account on your system, you should have a directory in here named after that user account. User accounts are something we'll talk about later, but for example on my system, I log in as Brian, and so in my users directory there is a directory called Brian. And the idea of this directory is that this is a place where I, as a user, can store any of my own documents, any of my own files, and also it's a place for any sort of configuration files used by any of my programs. It's basically a place for anything that's specifically about me, about my user account. And inside each user directory, just for the sake of organization, Microsoft includes these default directories, one called My Documents, one called My Pictures, and one called My Music. The idea is that any music you have, you would put inside the My Music folder, any document you create, you would put inside your My Documents folder, and so forth. Now, nothing at all forces you to put your stuff in these directories, but if you can't think of a better place to put them, you might as well use these directories. A while ago, I mentioned in passing that the icons on your desktop are actually really files and directories. For instance, here on my desktop, I have a directory named Projects, I have another directory named Pictures, and then I have this file called Business Receipts. What's going on here is that the desktop itself is really just a special directory. Microsoft decided that for convenience sake, users would want one special directory where the contents are always displayed behind all of their windows, because that, in theory, would be a convenient place to go to place frequently used files. Still, it is really just a directory, and in fact, if we go and find its actual folder, you'll find it at the path here d:/user/brian/desktop. It says Brian because currently I'm logged in as the user account named Brian. And notice the content you see here in this directory is the same as what you see on the desktop. And in fact, if I were to come here and if I were to delete the file, notice that it's now gone on the desktop as well as in the folder. What you're seeing here in the folder is really the same as what you're seeing here on the desktop. I'm sure you're wondering, how on Windows do you actually go about browsing through your files and folders? Well, the answer is that you need a program called a file browser, but Windows simply has one built in, and that's what most people usually use. To get to this file browser, you simply need to open any folder, like say here on the desktop if I were to double-click this folder and open it. Or you can go to the Start menu, and you can open one of these locations here on the right, such as Computer. Or down here on the taskbar, you should by default have this little icon here, and so I click that, and it pops up with the file browser. Now, the basic concept here in the file browser is that we have this pane on the left called the navigation pane, which contains a hierarchy of all of the locations on our system. Now, there are a number of really odd things going on with the location hierarchy here. First off, for some strange reason, Microsoft decided that the desktop should go at the top of the hierarchy. And as we just discussed, the desktop is actually a directory, and inside that directory I have on my system here two other folders called Pictures and Projects, but this other stuff listed, like say Recycle Bin or Control Panel, none of that is actually inside my desktop directory. You're only seeing them here as constituents of the desktop because Microsoft has magically placed them there in the hierarchy. And in fact, with the exception of Brian, which is my user directory, these things aren't actually really directories. The control panel, for example, is not a folder or file, it's actually a configuration screen where I can configure various stuff about Windows in my system. The item above it, network, is just a screen which shows you all of the other systems connected on your local network. Computer is the list of all the storage drives on your system. And again, Brian here is my user directory. Above it, the home group also has to do with networking, and in all likelihood, as a home user, your system isn't networked with any other, so you'll probably just entirely ignore this home group. The thing at the top here called libraries, well, that's really just a special selection of folders within your user directory. If I click on it here, it lists documents, music, pictures, and video. But documents here, for example, is really just the My Documents folder inside my user directory, and music is just the My Music folder inside my user directory, and so forth. So this is really just a shortcut to get to these particular folders. Finally, at the bottom, the recycle bin is a temporary storage location for deleted files. What happens by default when you delete a file is the file doesn't actually really get deleted. It just gets moved to this recycle bin location. And if you want to actually then delete the file, you go to the recycle bin and you hit the button that says empty the recycle bin, and then it will actually delete everything for good. The recycle bin feature was added simply because people tend to accidentally delete things, and so this gives them a second chance to go back and recover things which they have previously deleted but didn't mean to delete. Notice in the hierarchy here that many items have these little arrows on the left. When you click that little arrow, it will toggle the expansion and contraction of that node in the hierarchy. So here, for example, if I click the arrow next to computer, it will expand out the list of all the drives in the computer. If I click that arrow once more, then all of the drives in the computer will be hidden again. So, as I mentioned, the libraries here is really just a shortcut to certain directories that are also in your user directory. So that means in the location hierarchy on the left, you actually have two different ways to get to these directories. You can click on libraries and then click, say, on documents, or you can click on your user directory and then click on my documents. And the same can be said about the desktop directory. If I want to see the desktop directory, I can simply click on desktop at the top of the hierarchy in the navigation pane, or I can go into my user directory here and click on the desktop directory, and I'm looking at the same thing basically. And in fact, there's even a third way to get to the same directory. If I go into computer and then go into the drive on which I have Windows installed, which on my system here is drive D, and then I go into the users directory where my user directory is actually located, here Brian, I go in there and look, here's the desktop directory, and also here, say, is the My Documents directory. So again, the confusing things about this locations hierarchy is that some of the things in this hierarchy at the top aren't actually directories, and then the other confusing thing is that some directories show up at multiple places in the location hierarchy. And perhaps strangest and most confusingly of all, Microsoft seems to be telling you that your computer is something which exists inside your desktop, but then your desktop is something which exists inside one of the drives on your computer. So as it's presented here in this location hierarchy, the desktop is something which is inside of itself. Frankly, I think this all was a very stupid design decision, and they couldn't have made it more confusing if they had tried. Last thing to note here, you may be wondering about this star labeled Favorites. If I expand this, you'll see it's a list of locations. The idea is that there are certain locations that a user may wish to go to frequently, and so for convenience, the user can add that location to their list of favorites, so they don't have to navigate through the whole location hierarchy to get there. They can simply look in their list of favorites. If you look up in the right-hand corner of the window, you'll find this pull-down menu that gives you a list of different ways of viewing each location. Currently, I'm looking at this folder with the details view, which is the one I usually find most helpful, because it gives me these little bars at the top which I can click to sort things, either say by date, or by the file type, or by the size of the file, or by the name. By default, however, the usual view for a folder is the icon view. The icon view makes each folder and file look like it does on the desktop, as a square with a big picture and then the title underneath. Even though this is the default, I find it far less useful for reasons I won't get into. On the other hand, the one place it does come in handy is when you're browsing through images, because for an image file, the icon becomes a thumbnail of that image. So, for example, if I go into my Pictures folder here, and if I switch to the icon view, now I can much more effectively browse through all of my images. This is especially helpful here because, as is typical with image files, the names aren't very helpful. They're just like random letters and numbers. That just tends to happen, especially when you download pictures from the internet, because people are just very lazy about naming their files. Also notice with the icon view that you can actually change the size of the icons. So when you're browsing pictures, you probably want to go up to the extra large icons, as big as they get. But if you prefer, you can make them smaller. So that's icon view. Another view option is what's called the list view, and I really can't imagine who would find this useful. The list view simply shows all the files and folders listed out in columns. And unlike the details view, you don't have the helpful extra information of, say, the file dates or their file sizes or what type of file they are. The tiles view is like a variant of the icon view, but the name is placed to the right of the icon instead of below it, and also they throw in extra information like the type of the file and also its size. And finally, the content view is like the tiles view, except the files are all listed in one dimension vertically rather than also horizontally. So again, I recommend you simply stick with the details view by default, and then when you want to view through a bunch of pictures, then you can switch to the icon view. To open a file or folder, you can again use the context menu and select Open, but more commonly we simply select the item and then hit Enter on the keyboard, or we simply double-click that item. Like say if I wish to open the Pictures folder here, I simply double-click it. So this is actually one of those contexts in which single-clicking something selects it, but then double-clicking it actually opens it. You may be wondering what it means to actually open a file. Well, in this case, this is a Microsoft Excel spreadsheet, so if I were to double-click it to open it, it would open the file in Microsoft Excel. How exactly Windows knows which program to open this file with has to do with something called program associations, which we'll talk about in a little bit. Now, if you wish to create a file, normally that's done in applications, like say to create a Word document, you open Microsoft Word, you create some text, and then you save the file, and that creates a new file. However, for certain file types, I can right-click in a blank area in the folder here, and I come down to where it says New, and then I can say create a new Microsoft Office Word document, and that'll create a new file. It'll let me name it, and now I have this new empty Word document file. If I wish to create a new folder, I do basically the same thing. I click in a blank slot in the folder here, come down to New, and select Folder. Notice though, as a convenience, in the bar up here, there's a button for creating a new folder, so I click that and it creates a new folder. Now, to delete files or folders, I can again simply right-click them to get a context menu and select Delete, and it asks me, do you really want to delete this folder? I click Yes. Alternatively, I can select items and then hit the Delete key, and this time I'm going to select both of these items together. And I'll do so by dragging a selection box around both the folder and the Word document. And then I hit Delete on the keyboard, and again it asks me, do you really want to delete these two items? Yes, I do, and they're gone. What about moving them to other folders, and what about copying them to other folders? Well, the best way to do that in the file browser is to simply use Cut, Copy, and Paste. For example, say I wish to copy this hedgehog picture into the music directory on this drive. Well, I simply right-click to get the context menu, select Copy, and now that file has been copied to the clipboard. And now to actually copy that file into a folder, I navigate to that folder, and then I right-click in a blank spot within that folder and select Paste. And that copies the file from the clipboard into this directory. If I wish to actually move a file rather than copy it, when I open its context menu, I should select Cut rather than Copy. That again will copy your selection to the clipboard, but it will remove the items from the original location where you're cutting them from. And as usual, when you paste something from the clipboard, it still is there on the clipboard, so you can actually paste it as many times as you like. So if you wish to move or copy something into multiple directories, you can do so simply by pasting multiple times. An archive file is a file made up of some number of files and directories. All of those files and directories are taken together and bundled into just this one big file. The reason you may wish to archive many files and folders together into one file is that this sometimes makes it easier to transfer. Like say if you want to send a bunch of things to another person, it's probably best to put them together in an archive and send it to them as just a single file. A compressed archive file, as the name implies, is an archive file where the data has been compressed. The idea of compression is that there are certain techniques which can be applied to data to produce a compressed copy of that data. That is, some amount of data which is actually smaller, but then can be decompressed to get back the original data. So if we're going to be storing or transferring archives, it makes sense that we compress them so that they take up less space and take less time to transfer. The most common format for compressed archives is called zip, and zip files end in the extension .zip. The Windows file browser actually has built-in support for these zip files, so if you double-click on a zip file, it will open up and you can browse it just as if that zip file were like a folder, which in a sense it sort of is. It's something which contains some number of files and directories. The trouble, however, is that other programs can't necessarily browse a zip file as if it were just like a folder. And so when you wish to work with the files and folders inside a zip file, you'll want to extract them from the archive. And you can do this simply by navigating into the zip folder and then copying those files and pasting them to the desired destination folder. So effectively, you extract files and folders from an archive by copying them from that archive just as if it were a regular folder. Another special kind of file is what's called a shortcut. A shortcut is simply a file which points to some other file. The shortcut itself doesn't really have any data. All that gets stored in the shortcut is the file path pointing to the other file. Shortcut files are denoted by this little arrow placed in a corner of the icon. So here, as denoted by the arrow in the bottom left, this is actually a shortcut file. And it's not the file businessreceipts.xlsx, it's actually just a pointer to that file. Now, say if we were to delete this shortcut, or we were to copy this shortcut, we would only be affecting the shortcut itself, not the actual file to which it points. But if we open a shortcut, the file which actually gets opened is the file to which the shortcut points. So the idea of shortcuts is there may be some file or folder which we open frequently, but that file or folder is located deep in the hierarchy of folders, and so it's inconvenient to open that folder all the time. So to make it more convenient to get at, we can create a shortcut to that file or folder and place it in some place which is easy to get at, like say the desktop. So for example, I can create a shortcut to the business receipts file here by right-clicking the file and selecting Create Shortcut. That places a shortcut in this very same directory, so I'm going to cut it and then paste it on the desktop. And now conveniently I have an icon on my desktop which I can click to open that file. Shortcut files are fairly simple, but there is one subtlety to keep in mind. If you change the name of a file or folder being pointed to, or if you move that file or folder, then any shortcuts that pointed to them are now broken, because the shortcut only knows how to find the file or folder it points to by virtue of this path. If the path to the file or folder changes, then any shortcuts to that file or folder break. You're probably wondering how you go about putting programs on your computer. Well, first you should understand that there are a number of programs already included with Windows itself. These are programs which are installed by default when you install Windows. And they include a program called Notepad, which is just a very simple text editor. A text editor is like a word processor, but you can't do any sort of formatting with the text. You can't change fonts and you can't make things bold and so forth. It's basically just text without any formatting. Windows also installs a little calculator program, which you might find useful. Much more significantly, Windows includes Microsoft's web browser called Internet Explorer, and it also includes Microsoft's media player called Windows Media Player. And anytime in Windows, when you open a folder, a directory, the program which opens is called Windows Explorer, and it's an example of what's called a file browser. A file browser is just a program for looking through the directories on your system. It's arguable, however, if Windows Explorer is really a separate program because it's more like something that's integrated into the interface of the operating system itself. In many ways, it just doesn't really act like a distinct program. In any case, those 5 are probably the most notable programs that come included with Windows. There are a dozen or so others, like say there's a free solitaire game, but most of them just aren't very interesting. As I have said before, web browsing takes up probably over 90% of what most users do with the computer these days. So if you're content using Internet Explorer as your web browser, then Windows pretty much has everything you need right there. However, if you wish to do more with your computer, then there are programs which you can buy to install on your system. For example, the most notable programs you might consider buying include Microsoft Word, which is Microsoft's word processor, Microsoft Excel, which is their spreadsheet, Microsoft PowerPoint, which is their slide presentation software, and Photoshop, which is made by Adobe and is an image editor. Photoshop actually comes in a couple different editions. There are 2 which are intended for actual graphic designers for professional level work, and those are very expensive. They're like at least $700 when you buy them. But there's a cheaper version meant for just casual home users called Photoshop Elements, and that's about $80. Microsoft Word, Excel, and PowerPoint are also quite expensive, however they come in different versions. You can buy them individually, but usually people buy them together in a package called Microsoft Office. There's a cheaper version for casual users called Home and Student, and that's probably the one you want to buy. That's about $150, and that actually includes 3 different licenses, so you're actually allowed to install it on 3 different systems. If you're not interested in paying for software, there's plenty of stuff which you can legally download for free from the internet. Notable examples include the Firefox web browser and the Google Chrome web browser. I strongly recommend using either of those browsers over Internet Explorer. They're much better alternatives. There's a free alternative to Microsoft Office called OpenOffice, and it includes a word processor called Writer, a spreadsheet program called Calc, and a slide presentation program called Impress. And for image editing, there's a program called GIMP, which is an acronym standing for GNU Image Manipulation Program. And as a last example, while Windows Media Player is perfectly fine as a media player, you will find occasionally that there are some audio files or video files which you can't play back in Windows Media Player because it doesn't support those formats. So I recommend a free alternative called VLC, which has very broad support for all the formats out there. It plays pretty much anything. Now let's look at the files which make up a program. Files ending in .exe in Windows are called executable files, meaning they are files which can be executed. They can be run because they are actually pieces of code. So, properly speaking, the executable file is the program itself. Files ending in the extension .dll are what are called dynamic linking libraries. They are files which contain code which executables can link to at runtime, meaning the executable can use that DLL as additional code. In practice, most programs don't put the entirety of their code into the executable file, they put some in some other DLL files. So the entirety of the code is spread among an executable file and some number of DLL files. The term resource file is simply a generic name for some file of data used by a program. Like, for example, if a program has buttons with icons on those buttons, well, those icons are images and they have to be stored somewhere, and so usually they're stored in separate files called resource files. Now, it is possible to include data along with code in an executable file, and some programs may do that, but generally that's considered a bad idea when a program has a lot of data, so usually programs will load their data from other files called resource files. Many programs have some number of options which the user can set, and so if the user sets these options, those options need to be stored somewhere, and so those configuration options are usually stored in what are called configuration files. So let's look at an example program. Here's this program which I downloaded from the internet called VirtualDub. It's a video editing program, and what I downloaded from the internet was a zip file, a compressed archive. And when I uncompressed that archive, I got this directory, and inside the directory are all these files. So if you look here, you'll notice we have 3 executable files, and we also have 3 DLL files, And in addition to that, we have a file ending .chm, .jobs, and .vdi. Those last three are just some kind of resource files. It's data used by the program when it runs. Also in this directory, we have two more subdirectories. If you look in there, you'll find additional DLL files. It's generally important not to move DLL files or resource files, because when an executable runs, it generally expects to find these files in certain directories, and so if you were to move them, the executable would no longer know how to find them. This program is an example of the simplest sort of program to install, because it's one where all we have to do to install it is simply unzip a zip file, and then everything is in its place and we just run the executable file. Most programs these days can't be installed so simply, mainly because of this thing called the Windows Registry. The Windows Registry is a central registry in Windows for all sorts of configuration data for all your programs, for Windows itself, and so forth. Most programs these days need to modify the Windows Registry when you install them, otherwise they won't run. You can't simply unzip the program files into a directory and then run the executable. That doesn't work for most programs. So that's one big reason most programs these days are installed not by just unzipping a zip file, but by running an installer program. An installer program, as the name implies, is simply a program that installs another program. And this primarily consists of uncompressing the files and then putting them in all the proper directories and then doing whatever modification is necessary of configuration files and the Windows registry. So here's an example. If I wish to install the Firefox web browser, I go to the Firefox website and I download this exe file, this executable called Firefox Setup. Most installers in Windows are going to have the word setup in the name of the file. So when I run this installer, it first uncompresses all of the files. The executable itself contains all of the compressed files. And then, as is typical with installers, I'm presented with a window that's going to present me with some information and ask a few questions. So I click Next here. It's asking me if I want to just go with the default options or whether I want to customize things a bit more. I'll go with the default options and hit Next. It's then telling me which directory it's going to install Firefox in, and it's asking me whether I want Firefox to act as the default web browser. And this is the last question, so the button doesn't say Next, it says Upgrade, and I click Upgrade. Firefox goes through with the installation, and then when it's done, it tells me it's done, and asks me if I want to launch Firefox right then, and okay, that's fine. And Firefox is running, and we're done. And that's a fairly typical installation process. Other programs are more complex, or they're bigger, so they're going to take longer to install, or they're going to ask you for more questions because they have more options. But that gives you the basic idea. Now, because program installation typically does more than just put some files in a certain directory, you shouldn't uninstall most programs just by deleting the directory they're contained in. Instead, if the program has an uninstaller program, you should use that uninstaller, because the uninstaller program is going to effectively undo whatever was done by the installer program. Like, say, an uninstaller might undo some configuration that was done in the Windows registry. The place to go in Windows when you wish to run an uninstaller is this window in the control panel called Programs and Features. This window gives you a complete list of all the programs installed on your system, and you can click on a program here and then hit the uninstall button, and that will run the uninstaller for that program. As a program is improved over time, the new versions are given updated version numbers. And actually the versions of most programs are specified with two numbers called the major version number and the minor version number. And they're written with the major version first, followed by a dot, then the minor version. The general convention is that as you release only minor upgrades, you increment only the minor version number. Only when you release a new version which is significantly different do you increment the major number, and when you do that, you then reset the minor number to 0. For example, if the current version of Firefox is 2.4, but then you release a major upgrade, you would call that 3.0, 3.0. You also have to be careful to recognize that 3.12, for instance, is a later version number than 3.8, even though the quantity 3.8 is greater than the quantity 3.12. The way you're supposed to read it is that 12 comes after 8, therefore 3.12 is a later version than 3.8. So a good question is, when a new version of a program is released, how do you update your software? Well, with some programs you may simply have to download the new version and then install it just as if you were installing a totally new program. Some programs, though, are a bit smarter, and every time you run them, they will check on the internet to see if there's a new update, if there's a new version. And some programs will even go so far to automatically download and install the update themselves. When a program does this, usually they will at least prompt the user for permission to do so. Some users are apprehensive about new updates because when a new update is released, it may fix things, it may add new features, but there's a good chance it also may break some things. So some people like to wait a little while when a new version is released and hang back and see if other people have problems with the new version before they install it themselves. There's an idea that has caught on in recent years which you might call a software repository. A software repository is some kind of system, some program maybe, that downloads and installs and updates software on your system. So rather you, the user, having to manually download and install all of these separate programs, it's one central program that does all of that for you. The idea of such a system actually first showed up on Linux. On Linux you have this thing called APT, which stands for the Advanced Packaging Tool, which is this whole repository system. So a user on Linux, when they install software, they typically don't install separate installers, they just use their package management system to grab some piece of software and install it. And one advantage of this centralized system is it's generally better at automatically making sure that all of your software is up to date. In the last few years, this idea of a software repository has been picked up by commercial software makers. For example, Apple has created such a system for its iPhone called the App Store. App here short for application, meaning a program. And the idea with the App Store is it's one centralized location which a user goes to browse through available programs, and then they can purchase any of those programs and have it downloaded and installed, and then automatically updated when new versions are released. Steam is another such system, and it runs on Windows, and it's primarily about games. So if we take a look at what Steam looks like, it's a program which you download and install on your system, and then if you open it up, you're presented with an online store from which you can purchase and download any game. And then in Steam you have your list of games which you've purchased, and you can launch them from here. So for these games, it functions as an alternative to using the Start menu. And again, a very nice thing about this sort of system is you don't have to worry about keeping everything up to date. It automatically keeps everything up to date for you. Again, Steam is just about games. There isn't yet a well-established application store for just general programs on Windows, but it seems likely that there will be sometime soon in the future. We talked briefly about file formats and file extensions. For example, .doc files are Microsoft Word document files. When it comes to these file extensions, Windows has this concept of file associations, meaning which installed program is associated with files ending in that extension. If you go to this Set Associations window in the Control Panel, you'll see the list of all the extensions that Windows knows about and which program by default it will use to open that type of file. So here, for example, files with the extension .docx are opened by default with Microsoft Word. That's why when you open a .docx file, what you're doing is opening Microsoft Word, because Microsoft Word is currently the program associated with .docx files. Now, it turns out that OpenOffice Writer can also open and view .docx files. So if you wish to use OpenOffice Writer as your default application for dealing with docx files, you can go into this window and change the association with .docx files. However, if opening a .docx file in OpenOffice Writer is something you only wish to do occasionally, a better thing to do is just right-click on the file and then go to the Open With menu, and you'll be given a selection of different programs which can open that file. And so you can simply select there OpenOffice Writer, and that will open the file in OpenOffice Writer just for that one time. It doesn't change the default association. Underneath the hood, most programs are quite complicated things, and like all complicated things designed by humans, inevitably they're never perfect. Programs have imperfections which we call bugs. A bug is simply just some kind of undesired behavior of the program. And some program bugs may cause a program to just lock up, to freeze up and stop responding to the user. Hopefully this doesn't happen very often, but when it does, we need some means to kill a program, to get rid of it. When a program locks up like this, we can't close it by normal means. we can't just click on the red X in the top right corner. That usually doesn't work when this happens. So the way you can terminate a misbehaving program in Windows is to use what's called the Windows Task Manager. The best way to open the Task Manager is to use this handy keyboard shortcut of holding Control and holding Shift and hitting Escape. In the Task Manager window, you'll then see these different tabs. There's the Applications tab, a Processes tab, a Services tab, Performance, Networking, and Users. The two most interesting ones here are Applications and Processes. Applications here is just used as a synonym for programs. So Applications here will show you a list of all of your running programs. And you can terminate any program in this list by clicking on it and then clicking on the button that says End Task. If that fails to work, you can alternatively try to kill a program through the Processes tab. The list of programs you see in the Applications tab is actually sort of a lie. It's just a friendly gloss over what's really going on in your system. In truth, as far as your operating system is concerned, the programs that run are called processes. And so when you look in the Processes tab, you see the true full list of all the processes that are currently running on your system. The surprising part about this list is it tends to contain quite a few more processes than there are programs you yourself started. The reason for this is that many of the processes that run on your system are there functioning not as visible programs to the user, but as sort of background services, as we sometimes call them. Things that run in the background and manage various aspects of your computer. Most of these processes are actually, in a sense, part of Windows itself. For instance, in the list here, you'll see a process called dwm.exe. That's the desktop window manager, and it's actually the part of Windows responsible for moving your windows around and displaying them and so forth. So this processes list is a bit less friendly than the applications list. However, a nice part about the processes list is that it has a column here in the list for CPU time. For each process, it is displaying the percentage of CPU time which that process is currently consuming. So say if you have a process listed here where the CPU column reads 50, that means that process is currently taking up 50% of the CPU time. Knowing how much CPU time a process is currently taking up can be useful because sometimes what happens is that a process, when it gets in a stuck state, it gets stuck in a loop such that it is actually using the CPU but otherwise not doing anything useful. This may be bad because it might make the other programs in your system run much slower. So what you can try, if you ever find that your programs are running really slow, is to open up the Task Manager and try to identify any process that seems to be hogging an inordinate amount of CPU time, say upwards of 90%. If you find that there's a program hogging the CPU, you should first try and close it by normal means, and if that fails to work because the program has actually locked up, then you can come back to the process list and kill that process.